Hey guys, Jake here coming at you with another math lesson today. Today we're going to be talking about how to solve exponential equations using logarithms. So I'm going to be going through a few examples. I'm just going to show you how to solve an exponential equation like this. These are somewhat, simple beginner examples of what I'm going over. You may run into some that are a bit more complex. And I'll kind of touch on how you would go about something like that later in the video as well. But let's just go ahead and jump right on into it here. So really when it comes to these sorts of problems where you have something like this, solve for x and they give you, for example, 3 to the x equals 243. We can solve an exponential equation like this by using logarithms, by simply looking at what our exponent is, our exponential portion of this equation. So in this case, we have 3 raised to the x power. So basically all you want to do is whatever the base of your exponent is, in this case we have a base of 3, we would just take log base 3 of both sides of our equation. So whatever the base of your exponent is, you would do that base as the base of your log and take that, apply that to both sides of the equation. So we would take log base 3 of 3 to the x equals log base 3 of 243. Okay? So if you take that, what that's going to do is it's going to cancel the base exponent on the left side of our equation and just leave us with x equals log base 3 of 243. Okay? So then for that, you've already isolated for x. All you really have to do at that point is just evaluate this log base 3 of 243. Which you could just use the change of base formula, which I've discussed in another video. I'll put an info card up there so you can go check that out. But if you go watch that video, basically what it tells you is that we can plug this into our calculator as log of 243 divided by log of 3. So this is something you could actually plug into your calculator. And if you do that, that would give you what x is. Okay, so let's go through another example. What happens if you have log base, or if you have the base of your exponent is e? How's that going to work? Well, similar idea. We just want to take log base, whatever the base of our exponent is. In this case, we have a base of our exponent of e. Well, if you're taking log base e, that's exactly what natural log is. So natural log is just log base e. It has a specific shorthand, which they've shortened to ln of e to the x. So if you take ln of both sides of your equation, that's the same as taking log base e of both sides of your equation. So you're going to get natural log of e to the x equals natural log of 4 in this case. The natural log and the e are going to cancel, basically just leaving you with x on the left side of your equation equals natural log of 4. And again, natural log of 4 is now in a form that we can just plug that directly into our calculator. So real quick, before we jump into this last example and the kind of more complicated version that I said I was going to talk about, if you haven't already, be sure to go check out jakesmathlessons.com/precalculus-study-guide or scan this QR code in the upper right-hand corner of your screen. It's going to be a huge help to you if you study for tests in a pre-calculus course or as you do your homework in a pre-calculus course or college algebra, same idea. I definitely recommend you go check that out. It's available for instant download. This link will give you a ton more info so you can go learn more about that. You can literally have that in seconds if you just go to that URL right there. So go check that out. Okay, so now let's get into this last example here. So again, we have the base of our exponent is e. However, because of this 4 being multiplied by it, we're not just going to be able to go straight to taking the natural log, because notice in each of these last two examples, we had just our exponent on one side of the equation equaling some number. So we had 3 raised up to the x, e raised up to the x. In this case, we have 4 times e raised up to the x. So if we want to apply the natural log or the log to both sides of our equation, what we first have to do is figure out how to move this 4 over to the other side so that we have it in a form where taking just the log of both sides is actually going to cancel with the base of our exponent. In order for that log to work, we need to just have some number raised up to the power of something with x in it, like we're trying to solve for the exponent. So what we have to do first is divide both sides by 4. because what that's going to do is, since you have 4 times e to the x, that's going to cancel your 4 out and just leave you with e to the x equals 91 over 4, which now we have it in a form where if we just take the natural log of both sides, that's going to cancel the e. So if we take ln of e to the x equals ln of 91 over 4, now the natural log and the e will cancel, just leaving us with x equals ln of 91 over 4. Okay? So real quick, I just want to touch on what happens if you have something more complex. Like, for example, instead of 4 times e to the x equals 91, what if you have 4 times e to the 3x plus 2 equals 91? Okay? How's that going to work out? Well, it's going to be very similar to start. Again, you can't apply the log or the natural log until you just have your base raised up to some power with the thing that you're trying to solve for in the power, right? So keep that in mind. This natural log and log solving method is really only useful if you have a constant base raised up to your variable power when you're trying to solve for the variable that's stuck up in the power. So if you have like x raised up to the e, keep in mind, e is a constant. E is like pi. It's like 2.7. So if having all these letters throws you off, instead of e, imagine it's just 2.71 raised up to the 3x plus 2. Or, in this case, if we have x to the e, that's x to the 2.71. You're not going to want to use logs to solve something like this, where you have a variable raised up to a constant power. There's a different method you want to use for that. The logs and the natural logs, those come in handy when you have a constant base, a number base, raised up to a variable power, raised up to x, or whatever variable you're trying to solve for. So, same idea. We would want to divide by 4 first, divide both sides by 4. Remember, whatever you do to one side, you have to do to the other side, or else it's no longer equal. Okay? So the 4's cancel, leaving us with just, I'm sorry, not e, sorry, go back. That is wrong. Okay. So canceling the 4, wait, no, it wasn't. Sorry, I'm getting ahead of myself. The 4's cancel. So we have e raised up to the 3x plus 2. Okay, now we're on track. Sorry about that. Mistakes happen. Sometimes you got to go back a little bit and fix your mistake. Okay. But that's just math. That's how it goes sometimes. Okay, so now that we have e raised up to some power with, again, the power has the thing we're trying to solve for, now we can take the natural log of both sides. So if we take natural log of the left side, take natural log of the right side, the e and the natural log cancel, leaving us with 3x plus 2 equals natural log of 91 over 4. So notice what happened here. When we took e raised up to some power, when we take the natural log of that, it basically is going to leave us with whatever was in the exponent before. So whatever was in the power of e raised up to the whatever power, that whole thing just drops down out of the power, and now that's all we're left with on the left side of our equation. So now from here, we can just, simply subtract 2 from both sides. And then divide both sides by 3. So that would give us x equals natural log of 91 over 4 minus 2 all over 3. So notice, again, obviously this is kind of a complicated fraction. You can plug all this into a calculator and figure out what that equals. I'm not going to bother with that, but I'll leave that to you. So again, if you haven't already, check out jakesmathlessons.com/precalculus-study-guide. If you got some value out of this video, hit that like button for me. And if you want to keep this brain train rolling, just go watch that video right there. It'll tie in nicely with this concept. Thanks, and see you next time.